Welcome to the Builder pattern, one of the classic gang of 4 creational patterns. By the end of this video, you will be able to spot it in a real code base, understand why it exists, write a minimal version yourself, and know exactly when it is the right tool and when it is overkill. Imagine a class that represents an HTTP request. It has a URL, a method, headers, a body, a timeout, retry settings, and authentication options, most of them optional. If you try to handle every combination with overloaded constructors, you end up with a dozen signatures. If you collapse them into one, callers are passing null for 5 arguments just to set the 2 they care about. This is called the telescoping-constructor problem, and it is the exact pain the Builder pattern was designed to cure. Think about ordering a custom sandwich. You would never say, "Give me sourdough, turkey, cheddar, lettuce, no tomato, extra mustard," all in one breath and hope the deli worker keeps up. Instead, you call out each choice one at a time, and the worker builds it up step by step. The Builder pattern gives your code that same stage-readable construction flow, only the steps you call are applied, and everything else stays at its sensible default. The formal intent is, separate the construction of a complex object from its representation, so the same construction process can create different representations. The key players are the product, the thing you are building, and the Builder interface, which declares one method per construction step. A ConcreteBuilder implements those steps and internally assembles the product. An optional director knows a specific recipe and orchestrates the steps in order. The client picks a builder, optionally hands it to a director, and then calls a method like build to get the finished object. Let us walk through this code top to bottom. First, we define the product HTTP request, a plain class whose constructor takes every field it needs. Next is the HTTP request builder. Its private fields hold the work in progress state, with sensible defaults already set: get method, empty headers, no body, 5-second timeout. The constructor takes only the one required field, the URL. Each configuration method like method, header, body, and timeout sets the matching private field and then returns this. Returning this is what makes the calls chainable, that fluent style you see at the bottom. Finally, build assembles and returns the real HTTP request by passing all those accumulated fields into its constructor. The client creates a builder with the URL, chains only the steps it cares about, and calls build to get the finished object. Nothing is null, nothing is guessed. The key insight is timing. The builder holds intermediate state across multiple method calls, and the product is only materialized when you call build. This means you can validate all fields together at that single moment, rather than scattering checks everywhere. An optional director class can encode a named recipe, say build authenticated post request, by calling the builder steps in a fixed order, giving you reuse without leaking the construction logic into the client. The main trade-off is indirection. You now have at least one extra class per product, so for simple objects with 2 or 3 fields, this pattern adds complexity without real benefit. Reach for builder when your object has enough optional parts that a plain constructor becomes unreadable, or when the construction process itself carries logic worth encapsulating, like validation, ordering, or producing different variants from the same steps. Skip it when the object is small and straightforward. A typed options object passed to a function or simple destructured parameters will do the job with far less ceremony. The pattern earns its extra classes only when that complexity genuinely pays for itself in clarity and flexibility. To summarize, the Builder pattern separates how an object is constructed from what it ends up being. It solves the telescoping-constructor problem by letting you call only the steps you need in a fluent chain and collecting the fully formed product at the end with a build call. Remember the optional director for reusable recipes, and remember the trade-off. This pattern adds classes and indirection, so reserve it for objects complex enough to justify that cost.